Part 4, the last part of our lecture on 5.6. And I want us to start by looking at evaluating the integral of 1 over 4x minus 1 dx. And this is the first one that we've seen, which has the form part C, 1 over u or u to the minus 1. So in this situation, we let u equal the function on the bottom. So that's u equal to 4x minus 1. Then du is 4 times dx, which is not what we want to see there. We want to see a 4 here, so we have to make up for that by putting a 1/4 here. So the whole thing is then 1/4 times the integral 1 over 4x minus 1 times 4 dx. Now it looks exactly the way we want it to look. So we make the substitution, put u in for 4x minus 1, put du in for 4 dx. Now we can use formula C, which you can almost see. It's the natural log of absolute value of u plus a constant. 1/4 natural log of the absolute value of u plus a constant. And finally, we unsubstitute. Okay. The next problem is, in certain ways, shorter than the others. Let's evaluate the integral of 3x squared minus 5 to the 7th. We look for composition and we let u equal the inside function. If u is 3x squared minus 5, then du is 6x dx. And you look at this and you see, oh, we don't see 6x dx, we just see dx. So we're off by the 6. We've had that before, but we've never had a problem where we've been off by an x. And so you might think, oh, gee, can I put in 6x here and put 1 over 6x out here? You can do it with constants, but you cannot do that with variables. So we cannot fix up du when we are off by a variable. At least we cannot do it in the same way. There's some problems maybe that we could figure out something to do. So what this means is we cannot integrate by substitution here. And the book actually puts this in the instructions. It says either evaluate the integral or indicate that we cannot do it by integration by substitution. Now, you might wonder, what does that mean? Does that mean we simply cannot evaluate this integral? Well, let's come back up here and think about it. I can think of something to do that would allow us to evaluate this integral. we could multiply 3, 4, 5, 6, 7. Can't even write it all on there. We could multiply 3x squared minus 5 by itself. Actually, let me put one over here. 3x squared minus 5. You're starting to freak out, I can tell. One, 2, 3, 4, 5, 6, 7. We could, if we didn't have anything else to do, multiply this out. It would take a really, really long time, but then we would get this really long polynomial, and we could just use the anti-power rule and all those, you know, constants and everything. Way too long. And we're not going to do this. Our final answer for this one is this, actually. We cannot integrate this one by substitution. This just shows you, you know, I mean, well, it shows you the advantage. I mean, we could have had a problem where if we didn't have the x, then we might have still had our choice, you know, multiply it out or fix it up by substitution. But what this really makes the point of is, just because you can't integrate by substitution, there might be some other way of integrating it. There is another way of integrating this one. We just don't want to do it. And since we don't have to, we're not going to. Okay. So homework for section 5.6 is 1 to 45, the odd problems, and then 65 to 75 odd. These 65s to 75 odd, those are applications. But here's the thing. They are exactly the same sort of applications that you've seen earlier in chapter 5. It's just that you're going to have to apply the integral to a function where you use substitution. So there's nothing for me to teach you about the applications. All the teaching, all the new stuff you've already had. So I'm going to let you try those applications on your own. Okie doke, I will see you in class.